Okay guys, we make a start. In our last session we looked at paper 4, February, March 2024. Specifically we answered question 2. Today we want to answer question 3. So let's get to the page, and here we are. Okay, so we make a start. Question 3. This question is about acids, bases and alkalis. Table 3.1 shows the pH values of some substances. Okay, so you can see the table here. So let's go. The first question, A, define the term base. Okay, you know generally that we define acids as a proton or hydrogen ion donor. So in a chemical reaction, if something has to donate an acid, then there must be a substance that we accept to that proton. Okay, so if acids donates proton, bases we accept those proton. So we define a base as a proton acceptor. Okay, so here we go. A base is a proton. Is a proton acceptor. Okay, that gives you your 1 mark. A base is a proton acceptor. So we move. B, states what is meant by the term alkali. Okay, alkali. Alkali is a term used to describe a base that dissolves in water. So if you put it in water and it dissolves, then put a base in water and it dissolves, then we say such a base is an alkali. Okay, so some bases, you put them in water, they won't dissolve. But the hydroxides of group 1 metals are good examples of an alkali. Hydroxides of group 1 metals are good. So we are looking at sodium hydroxide, potassium hydroxide, rubidium hydroxide, and so on. Okay, so here we are defining an alkali. An alkali is a soluble base. So a base that you put in water and dissolves is referred to as an alkali. Okay, phenolphthalein is an indicator. State the color of phenolphthalein in a base and in acid, specifically in sodium hydroxide in an acid. So generally, an indicator is any chemical substance that can change in different colors. When you put it in an acid, it gives you a color different from when you put it in a base, a color different from when you put it in a neutral substance. Okay, so that is an indicator. Indicators are extracted from plants, so we have varieties of indicators, but there are specific indicators you should know for your syllabus. Now, phenolphthalein is one of such indicators you should know. Okay, so in any base at all, phenolphthalein is always blue. Okay, put phenolphthalein in a base, any base at all is going to be blue. But in any acid, phenolphthalein is colorless. Okay, phenolphthalein is colorless. A similar indicator that is in your syllabus that you should know is phenolphthalein. Phenolphthalein will also give you a colorless color in an acid, but pink in a base. Okay, all right, so we make progress to DI. Use the information in table 3.1 to identify the substances with the highest concentration of hydrogen ion. So we go to table 3.1. So this table 3.1. Now the table is giving us pH. I want to use the pH values to know the concentration of hydrogen ion. You know generally that the concentration of hydrogen ion to pH has a relationship. Okay, so the higher the concentration of hydrogen ion, the lower the pH. That's an inverse relationship. As one is going up, the other is reducing. The higher the concentration of hydrogen ion, the lower the pH. Okay, so you could tell here that the substance with the highest concentration of hydrogen ion is HNO3, which is an acid, which is nitric acid. Okay, so your response is HNO3. You're writing capital H and O3. Okay, you want to write your 3 as subscripts, and this is nitric acid. Okay, so what you are writing is HNO3 because that is what is on the table. Okay, HNO3, that's the name of the substance, or sorry, that's the substance that has the lowest pH and the highest hydrogen ion concentration. Okay, so your explanation, it has the lowest hydrogen, it has the lowest pH. Okay, it has the lowest pH value. Okay, it has the lowest pH value. Okay, by explanation why we picked that, or you generally know that the higher the concentration of hydrogen ions, the lower the pH value. Okay, so the higher the concentration of hydrogen ions, the lower the pH value. Okay, so we make progress. Name an indicator which can be used to identify the substance with the highest concentration of hydrogen ions. Okay, so generally you know that an indicator cannot tell you how strong or how weak. In other words, cannot tell you the concentration of hydrogen ion, okay, in an acid. Okay, because the concentration of hydrogen ion will tell us how strong or how weak an acid is. So indicator will not do that. The only indicator that can do that is the universal indicator. Okay, so you are writing universal indicator. Okay, so it's the universal indicator that is the only indicator that can tell you the concentration of an acid. You know, universal indicator is a blend of indicators, so it could change to range of colors. So with the range of color, we can tell that, oh, this is a weak acid, this is a strong acid, and so on and so forth. Okay, another instrument that can tell you the strength of an acid is the pH meter. But here we are asked to mention an indicator, not an instrument. I hope you get that clear. Alright, we make progress to the next question. Okay, so you have complete the equation to show the dissociation of ethanoic acid in aqueous solution. So acids generally dissociate, and when they do, they release the hydrogen they have as an ion. All acid must contain hydrogen. Okay, for hydrogen atom. Okay, so in this acid, the only hydrogen atom that is available to release is this one. These hydrogens that are here, three hydrogen atoms that are here are not available. They will consistently attach themselves to the carbon atom, so they are not available to release. So the only one to be released is the one attached to one of the oxygen. Okay, so if you are writing the dissociation, you are writing it such that the one hydrogen ion, and it has to be aqueous plus the remaining part of the molecule, which is H3 COO. Okay, that becomes an ion, and you put the state symbol AQ. Okay, so that is aqueous. Because this is a partial dissociation, you are going to put a reversible sign. Okay, a reversible arrow. So that is a reversible arrow. Now, by partial dissociation, we mean that if, let's assume that you have 100, this is hypothetical, if you have 100 molecule of these guys, if you have 100 molecules of these guys in the solution, you are going to have maybe less than 20, maybe 15, 13 of the molecules will dissociate to give you something like this. The remaining 80 something will stay intact like this. So this is a partial dissociation where all the molecules you have are not dissociating. Only a few of the molecules are dissociated to give you high. So the number of hydrogen ion in the solution will be very few, and so you expect the pH to be higher because the concentration is low. We have a higher pH of say 4, 5 or 6 pH. Alright, I hope that is understood. Now write the ionic equation which represents a neutralization reaction between any acid and any alkali. Okay, so this is like an ionic equation. Usually this ionic equation will end up as water. Okay, I hope you remember the rule that molecules don't ionize. By molecule we mean covalent compound or covalent substances don't form ions. You put them in water because they are not made of iron, so they don't form ions. Okay, covalent covalent substances don't form ion. Ionic substances don't form ion when they are solid. Okay, they only form ion, or in other words, solids don't form ions. When you dissolve them in water, they form ion. So we give example. Let's say you have HCl. Reacting with sodium hydroxide. This is going to give you sodium chloride plus water, right? Okay, water liquid, sodium chloride, because all sodium salts are soluble, so it's going to dissolve in water. Sodium hydroxide dissolve in water. Okay, we said hydroxides of group 1 metals are soluble, they are called alkali. We've mentioned that before. Then hydrochloric acid dissolve in water? Because hydrochloric acid is a strong acid, it's going to dissociate. Okay, acid generally dissociates in water. So you have hydrogen ion, it dissociates to hydrogen ion and the chloride ion. Okay, then sodium hydroxide is an ionic compound. Because it's an ionic compound, in a solution is going to exist as ion, sodium ion and the hydroxide or the OH ion. Okay, now what do we have? On the product side, we have mentioned that all ionic compound will always exist as ion in solution. So you're having sodium ion and the chloride ion in solution. And we've also mentioned that covalent substance, covalent compound will not form ion, they stay where they are, they stay the same. So water is a covalent substance, it stays the same as water. Now, ions that appear on both sides of the equations, we refer to them as spectator. Spectator ions. Okay, so we refer to them as spectator ions. Now, spectator ions, because they are just coming to look as it were, they are not really taking part. The ions that appear on both sides of the equation, we have sodium ion, we strike them out, so strike sodium ion out, is appearing on both sides. We have chloride ion on both sides, so we strike it out. So what we are left with is this hydrogen ion, OH ion, to give you water, and that becomes the ionic equation for every neutralization reaction. Okay, so we go back here and we write the equation. We say write the ionic equation which represents a neutralization reaction between any acid or any alkali. So pick any acid, any alkali, you will have the same thing. Okay, so you are writing hydrogen ion, AQ. Okay, because the hydrochloric acid is dissolved in water, and you have the OH ion, AQ, because the hydroxide ion is dissolved in water, and you have the liquid water being formed. Okay, so the equation is balanced. The ionic equation is balanced. Ionic equation, every equation, symbol equation, anytime you write symbol equation, you must always balance it. Okay, so we take this off, to get started. Alright, that's done. We can increase. Alright, so that's where we are. Now we make progress to the next question. The next question, G. Dilute nitric acid, HNO3, reacts with aqueous calcium hydroxide. See the formula for calcium hydroxide as shown. So we see that. Okay, so again, you could actually use this and you arrive at the same ionic equation. This is a neutralization reaction where nitric acid is reacting with calcium hydroxide, and you have a salt being formed and water. The only difference in this one is that we will have to use, we have to balance the equation. Okay, so the nitrate ion is going to appear on both sides. Nitrate ion, we are going to strike that out. The calcium ion is going to appear on both sides. We are going to strike that out. So what we'll be having left will be the 2 hydrogen ion, aqueous, then plus the 2 OH ion. Okay, aqueous, right? to give you the equation 2 water molecule. Okay, so you could just see the difference. The difference is having to balance the equation. So technically, you can see this equation and this equation, they are technically the same. The only difference we have there is the balancing of the equation. Okay, so for every acid, this is the simple ionic equation. Simple ionic equation. Okay, so we'll take this off and go back to our question. This has to do with calculation, so we make progress. Now we are told that 20.0 cm cube of 0.0150 mole per dm cube calcium hydroxide reacts with 25.0 cm cube of HNO3. Calculate the concentration of HNO3 in gram per dm cube. Use the following steps. Okay, the very first step, calculate the number of moles of calcium hydroxide used. Okay, so there are number of formulas to calculate number of moles depending on what you are given. So here we are given the volume, we are given the concentration of sodium hydroxide. So from there we could say that N, which is number of mole, is equal to CV, where C stands for concentration and volume and V for volume, N number of moles. Okay, N number of moles. So this is one formula you want to remember. So straight away, please note that your volume must always be in dm³. Your volume must always be in dm³. So we take our concentration 0.0150 multiplied by volume. Our volume is 20, but then we have to convert it to dm³ by dividing the volume by 1000. So at the end of the day, you have 0.0150 multiplied by 0.020. Okay, so if you punch your calculator, you are going to have 0.00003. okay, so you want to leave your answer to 3 significant figure, so you have that. All right, I hope it's straightforward. Now the next question, determine the number of moles of HNO3 which reacts with the calcium hydroxide. So what do we have here? We have this number of moles of, so no information is actually given for HNO3 for us to calculate the concentration of, the number of mole of HNO3. What we can do is to go back to the balanced equation. Go back to the equation and look at the ratio of the moles. So from the ratio of the mole, we have already calculated the number of mole for calcium hydroxide. Okay, so what we want to do now, compare the mole of calcium hydroxide to that of nitric acid from the balanced equation. So from the balanced equation, we could see that they are in ratio 2. Nitric acid is 2, calcium hydroxide is 1. So you write ratio 2 to 1 from balanced equation. Now from the information we have been given, we are able to calculate the number of moles of calcium hydroxide. So if calcium hydroxide is this 0.003, what will nitric acid be? Obviously you can say that you multiply this, it will be 2 times what nitric acid has. 2 times what calcium hydroxide has. If this is the mole of calcium hydroxide, then that of the nitric acid will be doubled. That is the information we get from the balanced equation. Okay, information we get from the balanced equation. So punch your calculator, just multiply by 2 and you have 0.0006. You want to leave your answer to 3 significant figures. Alright, that is pretty straightforward too. Now calculate the concentration of nitric acid HNO3 mole per dm cube. You come back to this formula, N equals CV. N equals CV. So you make C the subject. If C becomes the subject, N over V. Remember, your volume has to be in dm cube. Volume has to be in dm cube. So you convert your volume to dm cube. Now, so this is the same as the mole of nitric acid has been calculated to be this. So you have 0 over 0.0006 all over what is the volume of the acid used. Okay, reacts with this volume of acid. So the volume of acid is 25 cm cube. However, your 25 cm cube needs to be converted to dm cube. So divide by 1000, and technically you're having 0.0006 over 0.025. Okay, that's good enough. So calculator, you have 0.0240. Okay, to 3 significant figure. All right, great job. I guess you don't have any challenge there. Now we make progress. Calculate the concentration of HNO3 in gram per dm cube. So concentration in gram per dm cube. Concentration in gram per dm cube is equal to concentration in mole per dm cube. Mole per dm cube multiplied by mass of 1 mole. Mass of 1 mole is the same as molar mass, right? Molar mass. Okay, so molar mass of HNO3, we have 1 atom of hydrogen plus the A arrow of hydrogen is 1, the A arrow of nitrogen is 14. So you have 1 plus 14 plus 3 atoms of hydrogen times the A arrow of hydrogen, and that is 16. Okay, so you're having 15. 1 plus 14 to give you 15 plus 48. 3 times 16, that gives you 48. Okay, so adding this up, you have 63. Okay, so we've calculated the concentration in mole per dm cube to be 0.024. You are multiplying by 63 to get your answer. Okay, that's very fast. You have 1 point, so your final answer 1.512 gram. 1.512 gram per dm cube. You could just round up to 3 significant figures to get 5.51 gram per dm cube. Okay, so the final answer. Alright, I want to believe that you had a great time getting these questions solved. You could revise and get acquainted to how to go about this question. Alright.